Okay, so from this class on, we're gonna start the chapter 5. So chapter 5 is titled A Closed Economic One-Period Macroeconomic Model. Okay, so there's two key terms here. One is closed economy. So what is closed economy? That means there's no trade here. Okay, especially there's no, what I mean trade is international trade. Okay, so there's no trade outside of this small economy. Okay, and one period means there's no more than one period thing. There's no saving. Okay, you cannot live for two terms. In this simple model, you only live once. Okay, one term. Okay, and so the learning objective here is basically we're gonna combine the consumer and the firm from the previous chapter and show you how to construct a CE. CE. CE stands for competitive equilibrium. Okay, we will first define what is a competitive equilibrium and tells you how to construct it in this model. And we're going to show you that CE here and PO here is actually the same thing. PO stands for Pareto Optimal. Pareto Optimal is something that you should have learned in micro, but in here it's basically the same thing, but we define it maybe slightly different, or you might find it slightly different, but the general idea is still the same. Okay, and then this is a model, right? So we're gonna also talk about when the exogenous variable change, how the endogenous variable gonna change according to that. Okay, basically, we'll analyze the so-called comparative analysis of this model. So, and we're gonna also decompose the effect of an increasing Z, that total factor productivity, in the CEOP model into income and substitution effects. Because when technology improves, actually we also have this so-called income and substitution effect. We'll see how it's gonna work. Because like I said in previous chapter, Z is actually the main force that pushed the economic growth. Okay, so the change in Z is a very important factor that we need to consider. We need to see when Z change, what happens to the model basically. And then we will show you an analysis about how labor income tax is distorting the market. Okay, labor income tax means we tax on your labor input. Okay, means you work, I tax you. That's basically the income tax that if you one day graduate from this program and started to work somewhere, you need to pay the government tax. And usually the most of those tax are your income tax. Okay, and those tax are so-called distorting tax. Distorting tax is the idea that you should have learned in undergrad economic class, right? So distorting means that will make the situation less optimal than it should be. So without the tax, the production should be maximized or the welfare should be maximized. But with the tax, the welfare is actually distorted. And then we will also use this model, change it a little bit, and use it to analyze and determine so-called the size of the government and private consumption. Okay, so we'll show basically that, okay, we have this that simple CEOP model, but we can actually turn this simple model to analyze a lot of different aspects as long as we change some assumption in this model. That's what we will see in this chapter. Okay, so recall from previous chapter, we have the representative consumer, the consumer we learned last week, the representative firm, the firm that we learned last class, and use both of them, we can actually construct the CE. Okay, and then we will tell you when government spending increase or the total factor productivity increase, what does that change the CE? So recall that what is the economic model? A model is basically something that takes exogenous variables in and gives you the endogenous variable. Okay, so this is just like a simultaneous equation. You have, for example, x plus y equals 10, x minus y equals 3. Then you can solve for x and y, right? Here, what is endogenous? What is exogenous? The one in front of the x and y, and the minus 1 here, and the 10 and 3, these are exogenous variable. And when you solve for x, you know that x equals something, y equals something. The x, y here are endogenous variable. Okay, so for example, what in our model, clearly what is exogenous? Tax is exogenous. The dividend, pi, that's exogenous. Okay, and also the wage rate is endogenous. Yeah, something like that. Okay, we will see exactly what is exogenous, what is endogenous. So what is a competitive equilibrium? A competitive equilibrium must take a price first. So given a price, here this price, because here we only have one market really that has demand and supply. That's the labor market. And in the labor market, what is the price? Wage rate is the price. So we only have one price, that's W. So given some price W, and the consumer can optimize given this W, right? So the consumer, when he or she face a W, he decides what? He decides the labor supply. And the firm, like we just taught in last class, if I see a W, this given this W, this market price, I will show you my labor demand. And to make the market clear, we need the labor demand equal labor supply. So if labor demand is greater than labor supply, what happens? Labor demand is greater than labor supply. That means the wage rate is too low. So not that many people want to supply their labor. A lot of people want to demand that labor. So if suppose you try wage rate equals 10, and you find that labor demand is greater than labor supply, then you need to increase the wage. Okay, so suppose now you try wage equals 20 and you find labor demand is less than labor supply. What do? You decrease the wage. Okay, so then between 10 and 20, you might find that for wage equals 16, you have this, labor demand equals labor supply. Okay, so you find a wage that equalizes the labor demand and labor supply. And in this model, we also need that the government spending is equal to tax. Okay, here it's not that hard to satisfy because our government, we haven't really talked about government here, right? But here the government do one thing. It collected tax and spend it. And this government spending doesn't have any usefulness. So it's almost like you take the tax and you throw it into the ocean. Or you burn it. Almost like that. Okay, or you can think of it as to make the economy works so that the firm doesn't afraid of people stealing from them their output, or the consumer doesn't afraid that someone will rob them after they work. So the government use those tax and spend them. The G government spending were spent to help this economy work normal. That's the spending. Okay, or just think of it as burn it. That's fine. So this equation here is really easy to satisfy because no matter how much government spending we collect, we just spend them. So in the competitive equilibrium, the income expenditure and then they is satisfied. So it must be the case that you spend, so your consumption must equal to labor supply times wage rate plus pi minus t, right? That's, you supply that much labor, that's how much you consume. And pi is what? Pi is the dividend. The dividend must be what? It must be y minus the w times the labor demand. That's the dividend. We assume that all the dividend here, we assume that all the dividend goes to the consumer. And T equals to G. Then if you input this here, because labor supply equals labor demand, right? So if you input the pi here, this pi is y minus wage times labor demand. This wage, labor demand, labor supply cross out. And T is equal to G, so you replace this with G. Then you find that C equals Y minus G. So Y equal to C plus G. That's the income expenditure identity. Okay, if you don't know what I'm talking about, in intermediate macro, you must have see this. Y equal to C plus I plus G plus NX. You know what I'm talking about? Okay, NX is what? NX is net export, right? That is the term only exists when there is international trade. We don't have international trade, so this thing is zero. What is I here? I is investment. Investment is saving, basically. You need to be able to save. You need to have a model that at least has 2 periods to do something called saving. Otherwise, I mean, you only have 1 period. What do you save for? There's no future. So here we also have I equals to 0. So basically, this equation boils down to Y equal to C plus G. So I'm just showing you that Y equals to C plus G, something that must satisfy. Okay? Okay, and for the production function, okay, so this is what the C will look like, also the income expenditure identity. Now I'm going to go through a different angle to show you what the C would look like graphically. Okay, so we know that Y equal to Z times F, right? And since this labor is H minus leisure, right? That's how much hours you have. H is also something exogenous. That's exogenous. Leisure is endogenous variable, but we will know exactly how much leisure you will take because given the wage, I will know how much you work. And basically, I know how much is your leisure. Okay, so but here, I'm going to just replace N with H minus leisure because I want the variable leisure. I don't want the variable labor. Okay, and then, okay, this gives us, so K, H, Z, those are all exogenous. So there's only 2 variables here that's not sure. That's basically Y and L. So here, this equation gives us a relationship between Y and L, right? So this is a variable that I haven't really solved yet. So this are exogenous. So this is a relationship between Y and L. Okay, and we also know that in equilibrium, C equals to Y minus G. So we can further replace Y becomes C plus G. Or put it another way is C will equal to Z times F of K of H minus L minus G. I'm just replacing the variable with something we know in equilibrium. And this now become a relationship between C and L. This become a relationship between C and L. Because other than C and L, G is also exogenous. Okay? And if you draw this relationship, okay, let's do this one by one. This is here now. Okay, this is the production function. Okay, and the slope is MPN. This function can gives you the output as a function of leisure. That's relationship between y and leisure. So y and leisure. That's this equation. Further, we can get something from C, between C and leisure. Basically, that's this thing's minus G, and basically this whole thing is moving down parallelly for G. That gives you this. This is the relationship between C and L. And the slope is going to be minus MPN, because this one and this one is just an image, a mirror image of each other. Okay? Because remember, what I do here is I basically replace the N, the labor, with H minus L. So really it's a mirror image. It's just, I'm counting down your labor as something increased, or H minus leisure. That's also labor, but now in measure of leisure. Then when you increase the leisure, it's the same thing as you decrease the labor. Right? So it's this to this is a mirror image, and this to this is just parallelly moving down by G. And this one here, this line, is what we call PPF, the Production Possibilities Frontier. That basically tells you what is the relationship between consumption and leisure. That's basically what this society is capable of, as give the consumer the combination of C and L. For example, this point here is an impossibility point, where it means this society, no matter how you combine capital and labor, how much labor you input, there's no way that someone can have that much of leisure and that much of consumption. It's impossible. In terms of technology, we cannot do that. Okay, so remember, in principle of econ, you should have learned this. Like, you can draw a PPF for a country. Like, you said that, for example, this country will produce rice and airplane. So you sacrifice airplane, then you can grow more rice. But if you push all the way to produce 0 rice, then you can produce a lot of airplane. But if you want to produce a little more, a bit of rice, then you need to sacrifice the airplane. That's also called PPF. It's the same idea. That's the combination there is rice and airplane, and here the combination is consumption and leisure. It's the same thing. Okay? So, and if we already have this PPF, what is really a competitive equilibrium? From another point of view, is that can we find a wage rate so that the wage rate must first tangent to this PPF. The wage rate must tangent to the PPF because that's basically wage must equal to MPN. Wage must equal to the MRS. Sorry, I said it wrong. It's MRS because that's the more about the person's preference. Sorry, I was wrong. That's the MRT. That's equal to the MPN. That's the first thing I said was correct. So the first thing that I need to do is this purple line must tangent somewhere to this red line. And the second thing is that the indifference curve that the production that the consumer has must also tangent to this purple line. And this two tangent point must be the same point. Okay, so what I mean is, for example, if the wage rate is like this, probably not the best part like this. Okay, so suppose the tangent point is here. Then the preference maximization point, the utility maximization point probably is here. Then this is the point where the wage is equal to MPN, or same thing is also equal to the marginal rate of transformation. That's the so MPN is what I mean by labor, the relationship between labor and the wage. And MRT is the relationship between L and the consumption. But they are the same thing. Okay. So in this graph, they are the same thing. And then this point is where wage equal to MRS of I and the C. Remember, in consumer, you also need the wage rate to be equals to my own preference between leisure and consumption, so that that's how I maximize my utility, right? And so this point and this point, in terms of like, if I draw the wage to be the red line here, then you will see that the 2 points are not the same point. Then I know that this wage is not the competitive equilibrium. Okay, so for a wage to be a competitive equilibrium, it must be like this. Okay. Happens to be the case that this line tangent here and this line tangents the point here as well. So they are tangent to each other, and this tangent point also has a straight line tangent to both of them, basically. So because W equals MPN equals MRT, W also must equal to MRS. So these 2 points equals to, these two things equal to each other as well. So this one and this one, all the same. So really, if, for example, in the exam or in the homework, if you were asked to find a competitive equilibrium, what is the most crucial thing? How much someone produce? How much someone work? Or how many hours he takes as a leisure, or how much he consume? Are those the key variable that you should find? No. Those are part of the CE, but the most important thing that you should find is the price. So CE is basically defined based on that price. Because given that price, the other things are much, simple to solve for. So if I ask you for a CE and you give me a price and that price is correct, then you at least get half of the points for that questions. And the rest totally stands up to maybe half, if not less. But if you don't give me any price, but you give me a bunch of variable like consumption, leisure, output, but you don't have a price, then you lose most of the point there. Okay. And what is Pareto Optimal here? Okay. Pareto Optimal here is actually pretty simple. We don't have a market here. We're asking that given this PPF, the consumer, if there's a God that decide how much this consumer, what is the bundle that this consumer is going to consume, then what will happen? It will basically find a point where the purple line tangent to the yellow line. Right? Basically this is your technology. And this is your preference. You try to maximize your preference given your technology. So that point, when this line and this line tangent to each other, that's when this God can try to maximize the utility for this person, for this consumer. So that's why this is called PO. By definition, PO means there's nothing you can do to at least make one person as good as he used to be and make the other person all increase in terms of utility. Here, there's only one person who has utility, so we just maximize that person's utility. Is the PO. Okay. But this one looks pretty similar to this one, right? The only difference is that whether we have that price there. So, and because if these two tangent to each other, we can definitely find a price that support both of these two. That means that's tangent to both of them. And that's exactly the same CE price we found in previous page. Right? So that's how I showed CE implies PO and PO also implies CE in this model. That, if you recall, is the first fundamental theorem of welfare economics and the second fundamental theorem of welfare economics. The formal statement sounds like something like CE implies PO. Means if you have a competitive equilibrium results, then that equilibrium is also a Pareto Optimal result. Also, given any Pareto Optimal results, I can always find a CE to support that PO. Here, they are actually the same thing. So there's only one CE and there's only one PO, so they must be the same to each other. Clear? Most students find it difficult to really understand or to get the idea of CE. Okay, so if you think you already understand, try to read the textbook. Oh, by the way, if anyone need help to buy the textbook, you can contact the TA first and let someone like your maybe Bandai or someone can gather the number of textbook that you need and ask the TA. I will let the TA to contact the the firm that sells the book, to sell you guys the book. Okay. So yeah, my point being, what was I going to say? I forgot. I remember now. So if you feels like you understand what I'm saying, try to read the textbook again. Make sure you understand what is CE. Okay, because this idea is going to come back more than once, actually several times throughout the whole semester. I will ask you to show the CE of a model, construct a CE of a model. And what I found from last year and also before is that people find that part is the most difficult part. You might feel like you understand, but you actually don't. Okay, so like I said, in this model, the CE and PO are identical. Okay, and so like I said, this is the first and second welfare theorem. Actually, these theorems apply to any macroeconomic model, not just this model. But, well, as long as there's no distorting tax. Okay, so we will actually show them for other models as well. But you need to. This one is the easiest one. Okay, so try to make sure you understand what I mean by CE is PO here. Then from now on, later on, you'll find those models that more complicated model easier to understand. Okay, so in this model, another way to determine the CE, since we know PO is CE, right? So it might be, like in this model, we know we have this indifference curve, right? This must be something that the I gives you, because that's the preference, that's exogenous. And also this relationship between C and the L is from the production function, also exogenous. Okay, the relationship is not, it is exogenous. So based on these two things that are exogenous, you can actually solve for this point B. You just do a constraint maximization. Okay, so constraint is this, and your maximization function is this. And you can find this point B. And that point B, given that point B, you can find a straight line tangent to that point B. After you find that straight line, this straight line, then you ask for the slope of that line. The slope is the competitive equilibrium price you ask for. And you will find the leisure and the consumption here. And this is the G here, and this is going to be the C plus G, that's Y. So given you find a PO, you can easily find a CE that supports it. So you don't really need to try so what I'm trying to say here is that originally what I told you about C is that you need to try a bunch of different price, remember? Or you need to construct a labor demand function and construct a labor supply function and find the equilibrium based on the supply and demand there. But I'm telling you here that for this model, there's a simpler way. You simply find the PO first, which finding PO should be easier here. And after you find a PO, because PO equal to CE, you can easily find a CE. Got it? Okay. And now I'm going to talk about what happened when G increase, the government spending increase. Okay, this, like I told you last week, this is basically a pure income effect, right? Because G increase, remember in this model, G equals to T. So G increase is T increase. Like last time, T increase means the person just has less to spend on because the government collect tax from him. Okay, so C must decrease. This is pure income effect. You are poor now. So C decrease, leisure decrease. But what happened to Y? Y equal to C plus G. Right? Y equal to C plus G. G increase, but C decrease. But I can tell you pretty sure that Y will increase. Why? Can someone has the intuition to tell me why? Not very difficult, actually. I just want to show you that you don't actually, next time I will actually draw a graph for you and show you graphically, but here you can actually use your intuition to figure out why. No? Try something. I mean, it could be wrong. You could be wrong, but you also could be right, right? Just try it. By the way, if you are not comfortable answer a question in English, you can answer them in Chinese, like I said last time. Okay? So again, Y equal to C plus G. I know for sure G increase. That's the presumption here. I let the G increase. And I know C decrease, L decrease, so C here decrease, right? But somehow I know this decrease is less than this increase if I put absolute term in front of it. And so I know Y must be increase. But why? Is there an intuition here? Sure.
It's like because your leisure is decreased, and so that you have more time to work for your consumption or your income. So that Y equals to the products f of K and capital and leisure with capital is fixed, so that your H minus leisure is increased, so that your Y is increased.
So you're trying to say Y is actually Z times F of K and H minus L, right? So your leisure decrease. So these things must be increased. And K is fixed, Z is fixed, everything's increased. That's what you should say, right? Okay, that's one way to say it. Actually, he's correct. So this is one way to look at this. But there's another way to look at this. It's even simpler. That is, the increase of G has this wealth effect. And this wealth effect actually pushed two things to happen at the same time. That's C decrease and L decrease, right? So this is like this force was split into C and L. So totally the difference in G, so-called, this is not really the equal sign, but I will use something like approximately the decrease of consumption plus the decrease of leisure. So this must be big relatively to this. These two are gonna be small. So this is small, this is big, and totally Y is gonna go up. And wage must fall, but this one is pretty clear because this person must sacrifice leisure right now, right? The leisure decrease. And when the leisure decrease, it means the labor supply goes up. But for the firm to demand that much labor, the market is still in equilibrium. It must be that the wage rate goes down so that the firm want to demand that much labor. So the wage must fall. Graphically, it looks like this. So the PPF, the whole thing will goes down by the difference. This is delta G. This is difference in G, or how much increase in G. And then, so originally, my optimization, the PO point is here. Remember, PO is CE, so I'm not gonna talk about CE here. PO is CE anyway. Okay, so the point A is the PO in originally when the G equals to G1. And when G now equals to G2, the new optimization point is B, so B is the new PO. And you can see, compare A and B, leisure goes down, consumption goes down, right? This is delta C, this is delta leisure, delta L. And what is delta G? This is delta G. This is equal to this, right? Because it's parallelly goes down. And you can easily see that C, delta C is less than delta G, right? This green line compared to, this red line, this one is big, this one is small. Just like the intuition I gave you. Or graphically, you can see that this is the force that takes everything goes down, but it's split into two forces, this one and this one. So these two forces, one is the delta leisure, one is delta C. So both of them, delta leisure and delta consumption, are both less than delta G. Clear? Is that intuitive, or actually feels like it's more difficult to understand? Any comment? If you feels like this way of telling you why the Y must goes up, or delta C, the absolute value of delta C and absolute value of delta L is less than delta G, is easier to understand, raise your hand. Okay, at least some of you. Okay. If you feel like the way that Guorong offers is easier to understand, go that way too, but I would suggest you to try to understand what I'm trying to say here. This one should be the one that's easier to understand, and also better in terms of training your economic intuition. Okay, so like the most famous sort of government spending increase is what happened in the United States in World War II. In World War II, the famous thing is that the U.S. government started to move a lot of the private consumption firm into production of military equipment or material. Okay, so it has a very large increase in G. So what happens is Y will actually increase, but the C will decrease by a small amount. So that's what actually happened in World War II. That's also, by the way, why a Keynesian economist might tell you that, if you see the GDP, goes down, or the growth of GDP goes down, we don't have enough so-called economic growth, then a way to solve the problem is spend more money on the government side. Remember, in this model, like I said before, G, you can think of it as what? As you collect the tax and you burn the money. Or actually, we don't really have money here. Okay, actually, everything we talked so far in this, actually for the whole semester, we're not gonna use the money term. Think of it all as real term. What I mean is what we're trading are all rice or machine or some output. Okay. And we are gathering this output from the consumer using tax. And after we collect this tax, we burn these things or we throw them into the ocean. It's total waste. But somehow in this model, Y will still increase. So in terms of GDP will grow. A little bit like magic, right? Okay. And this is the relationship between GDP consumption and government expenditure. And if your high school history is not that bad, you will recall that the World War II happens around here, right? Okay, so you will see that this is G, this is GDP, this is consumption. Okay, you can see when the government spending goes up like this, it's a huge amount of increase. The GDP will actually increase, but the consumption actually goes down by a little bit. This is this is G's increase. This is Y's increase or GDP's increase. This is true data. Okay, so release that. Okay. Next one is the effects of an increasing Z, or effectively the same thing as an increasing K. Okay, this one, the PPF will shift out. When the PPF shift out, become steeper, there will gonna be, this is like the wage is different. Okay, so the price is different. Then we will have something called the income and substitution effect happening at the same time. And that's going to be more complicated. We'll talk about that next week.